Yeah, I think we probably start. So people probably still stuck in lunch. And today we will talk about how RISC-V, how we push RISC-V to do the kernel upstreaming even before the chip comes back from the factory. So actually, in most of the work, the upstream work is not done by me, but actually the work, initiation is all by me because I'm the customer of the SoC, RISC-V SoC, probably the biggest customer. So I had to push that to get it done. Actually, this talk is being presented back in the NIST conference, and as well as in Boston, because I think I circle around the world and make sure everybody understand the importance of upstreaming, especially for the hardware. And most of the hardware guy doesn't understand it, and the software guy understand it, but usually really hard to push hardware guy to do anything. So even on ARM, they didn't do it perfectly. I think x86 is definitely better. And I'm going to repeat the talk, but we add a little bit more progress on our chips. So the talk is all about precision upstreaming for RISC-V first ever, and then we set up the role model, and now set a very high bar for the coming SoC. So because one vendor already done it, and then most of other vendor had to follow anyway. So that is the good start. Even though it's not perfect, but it's good start. So myself is Liang. I'm a software guy, and I used to do Java VM porting and compiler, porting and writing all the backends. And then I'm a founder of the deep computing. I found it during COVID after I sold my software startup. And then, you know, when we do compiler, usually we really arrogant. We think we're the best software in the world, software engineer in the world, and we don't even look up onto the kernel side either. So we think that we're the most prestigious software engineer, very serious. So, you know, Alan Key says one word, you be serious about software. I'm sorry that you make all your money, and now you had to lose it all on the hardware side to improve it. So, that's the story of me. So, and then I start making RISC-V laptop, and even for very slow CPU. But actually, on the hardware side, it's not very slow. If you look at all the Chromebook of ARM, similar 4-core and 8 gigahertz, you should be able to run Chromebook. So why so slow? Yeah. You know why it's slow? We are software guys, right? So I make the most expensive laptop back in 2023. You can look up. Everybody saying I'm a scammer. $5,000 each, and with NFT. So I know Trump is in charge. So and that's why I make sure it's worth something. And lucky enough, and the British Computer Museum have one of them. So mark the stage. And in 2004, I made a very cheap one, and it's an 8-core, much better performance, much more RAM, and a very usable one, and very cheap, all the way from 5,000 to less than 500. So, and it runs Fedora and Ubuntu. And later on, I found it out I should not waste all my money on something that cannot scale. So I just want to put something on RISC-V, and then when I use it, I just realized that 99% of money has nothing to do with RISC-V. And then one of my friends saying that, why don't you partner with Framework? I said, what the hell is Framework? That's back in 2005, earlier 2004. And then I got introduced to Ninav, the CEO of Framework. And then, oh my God, it's a laptop that can change motherboard. Man, I just find, okay, I can save 90% of the work. I just focus on the motherboard. So that's multiple architecture support and upgrade motherboard. Because I make every 6 months have a new SoC coming out from RISC-V. I make motherboard more than anything else. So every 6 months have a new version. So that's perfect partner. So framework needs us to promote their open hardware, not just x86, AMD or whatever. You know, they open source all the document, but no one use it. And I'm the one using it and find out all the problem. So it's perfect partners. So we redo the 4-core because I'm trying to understand how the logistic partnering works. So there's nothing to do with kernel apps. And then last year I do a very powerful one, 5-TOPS AI and 64-gig LPDDR, and then 8-core. And the only thing is not good enough without vectorized. So the memory movement performance is not good. And also it's by chiplet. That's going by the NUMA. So it's a lot of performance impact. And whoever buy that version from us for the first patch, they earn money because 64 DDR is worth more than worth the whole framework laptop. So that's a joke. So and now it's coming. So this is proper usable one, really usable. You can use daily, and with a lot of kernel support, 6.12, 6.18, and even Upstream. And then I will talk about the story Upstream. So RISC-V versus ARM upstreaming. So I used to run Nokia's mobile phone, and this is not Linux. It's everything closed source. So I see ARMs. Any chip comes out using ARM IP, we scale to KK volume. We got it in millions. It doesn't need upstream. No need. Right? They make a lot of money. Right? MTK, Rockchip, Allwinner, Marvell. They make once the chip out, you have an ecosystem. You make a lot of money. But RISC-V is not. I don't know whether you guys can see it clear. RISC-V is definitely not. Just now, even we see that even the same hardware running the same Linux, similar hardware to ARM, 4-core, 1.5 gigahertz, you cannot possibly run Chrome OS or the decent performance in Linux. You know why? Because at that time, the kernel, the toolchain, the stack of software is not optimized. So the first version of motherboard, I find it very funny, is that you have an old hardware running newer Debian is faster than the old versions. Weird, isn't it? Right? Usually, like Apple, they put more new software running the hardware is very slow. Right? So it's weird because RISC-V software is getting better and better and better. So that is why RISC-V's future is on the future software. It's not your current software. So that makes the difference. We had to upstream. If you don't upstream, you have no futures, right? Because, and I take a look example one here. So we have the first motherboard J710, you know, and the IP is 2018, the CPU IP, and the SoC is 2022. And then I make the motherboard is 2024. You can see actually 6 years. But upstreaming, the first upstreaming started the pin control is February 2023. And then now the display controller and the DRAM all these are still stuck. So you can see an SoC, because the capacity of it, it takes forever to upstream. Then you start understand why ARM not doing upstreaming. Right? Any ARM SoC not doing upstreaming. Any of the mobile phone, they don't want to do Android upgrade. Right? So that is the reason. And then the East Wing one, even even tougher. So, and the 50 top AI. So the IP is year 2020, and the SoC is year 3, and then the motherboard is the last year. So, and then the CPU IP now is not even finished upstreaming because coherence is different from ARM. It's affecting all the architecture. So basically, I make the motherboard for it, make the product for it. I'm stuck with the old hardware, old software. Saying we're dead, right? Literally dead. Your kernel is old. Anything above is old, unless people backport all the features. So who's doing the backport? SoC, they move on so quick. They're not going to put effort on it, right? So I'm stuck. So I feel all the pain of it. And then, and back on, actually, and then I spoke to Greg. I said, how on earth back in x86, you know, in the old days, and how x86 does? He said, you can actually, you can get everything up before your chips out, FPGA, whatever, just do the upstreaming, even just make sure you compile, otherwise none is going to kill you, right? And doesn't run, doesn't matter, because the hardware is not there. No one can verify it's not run, right? Isn't it? So that is the difference. So, and then I say, I need to go back to x86 approach. So that's it. That's 20 years old slide. Amazed. So basically, I think most of the people doing the kernel, I think the first generation the kernel guys x86, the second generation kernel guys ARM, and most of the RISC-V guys from ARM. So they forgot all the pain. Yeah, because the ARM just make business, it doesn't need futures. Right? So, and that's why I pushed the RISC-V is going on this, and then we managed to do something before the after the tape out, and then start doing all the. It's not exactly the same, but slightly better, but still very late. We can't do the kernel code submission before tape out, and I don't know why, but I'm not making CPU, so and it's still behind this, but still better than now. So and because no one had done it before, including me, all right, and then we do a lot of funny things, saying that okay, and ask the spaceman, do you want to do it? So I'm threatening, but actually I don't have any choice. I say, if you don't do it, I'm not going to buy your chip and make the motherboard for you. Right? I just threaten them, but they are my friends. So, and then I say, no, okay, I help you to do it. Right? Even though I don't know how to do it, right? I never do any kernel upstreaming at all. But I find a few friends just in case I need to do it. And the manager convinced the founder of it. They said, let's go. Let's do it, okay? And still don't know how to do it, right? And funny enough, because space may have a few maintainer, and they are so conscious. They say my reputation, I never done this before. I always wait for the hardware, compile, runs, and upstream. I never lie. So I never do anything before. Really going to hurt my reputations, right? Even though Greg said, bug, kernel have bugs. Otherwise, we won't have 7.0, man. The 1.0 will be perfect. So, but anyway, so and more fun is that we take a look. How much work is how do we inherit the previous chip? So, and Space have done 2 chips. One is K1, and now the one is K3. Actually, we find very good things. We have 60-70% of IP is inherited. So that saves a lot of work. K1 is already took 2 years upstream all the way beside except display controller. which is really awful. I had to fix it in 2 months. So, and because space, I forget out K1. I had no resource for it, so I had to fix it myself. And then that is the convincing to do. So then we start. I convince somebody to do it. I just talking about the story more than technical things. I think the story is more interesting than the technical, big technical code that AI can do. So I said I write a long email with all maintainer involved, and then I send out this architecture. You know what email it comes back, and then Greg write a long email. Who the F decided this chip? Anyone spot any problem? So basically, the main problem is that they have a symmetric cluster. So in RISC-V, have two worlds. One is PRIT, RV23. One is RV23. So RV23 dictates the API, what instruction you support, work this, right? Man, now you have two clusters supporting different instructions. Oh man, go bananas! The whole thing go bananas, you know. And plus, we have finding out, you know, ARMS, the way you're doing PCIe is very slightly different from K3. Then all these things go pop up, all the hardware pop-ups. The problem works up. So, and you know, and more, it's basically unfixable. So actually, 16 core now you will see on my hardware. Go to RISC-V booth, then take a look. It becomes 8 core, one cluster. So you cannot see the other a small core. So that small core is completely wasted in general computing. You can only use it for AI. And even more complex is that how I'm going to use AI? How we divert all the AI capability or whatever onto the cluster own? That makes the whole software system complex. So that we learned that actually specific upstreaming, you can ask the software guy to help you to review the hardware. Right, and then you don't make mistake. I think, and the reason why they do it that way is because it says that, and the kernel, why you have big core and little core, this is inherit from ARM. But ARM doing very clever, same instruction, both support. No matter, it's just performance slower. But on RISC-V, it's not, for example, they were saying, why do I need a small core run hypervisor? There's no need. Right? Why a small core? You know, I just put small core, small area in order, blah, 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 blah. Yeah. And that is the hardware guy's mind. But it creates the whole software ecosystem so awfully complex. I haven't think about how do I run the AI separate just on the small core in order with AI instruction, customized instructions. And with RVV different V length. So there's very complex things. And more when we start upstreaming, because the hardware is not coming out, and then all the device tree is funny, right? Say, what name we're going to use? Because this is called FPGA. And then they say, no, don't have FPGA, because no one going to have your FPGA. You will not be able to build anything for your FPGA. Then we had to come up with a name with the first product, but we don't really know what's the first product. I said, and we just pick pickle, okay, whatever it means. So I was saying they pick penguin, right? Probably when I do a CPU, I will do that, you know. So a lot of things never done before. We make a lot of mistakes, but that's the purpose of how we're going to improve it, right? So we improve it with saying that, right? In the design stage, we actually on the FPGA side, we can verify all, we can upstream all the kernel code and related to CPU straight away before tape out. Once you verify on the FPGA, you all those hypervisor, customer instruction, blah, 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 blah. All these CPU-related features you can upstream. And you separate the CPU feature out of the SoC features. So for the SoC one, you have to make very consistent. Consistent means that take a look, the kernel tree, take a look, ARM SoC, well, IP they use flipping the same one. Then you have all the drivers someone has done for you, right? Then you are not going to be in pain for rewrite the driver and upstream it, right? So that we're saying the consistent. Pick someone already done before, and the kernel stream upstream can have the driver, the support, and you don't have to do it yourself. That means that I made a SoC, our software guy have less software guy, less maintenance, very perfect, right? So that's why we say a consistent design. And also, I went back to it, just commit the code, make sure it compile, minimum, right? No shame, and pick that it just need to be enough. So, and that's all actually for the experience of it. And actually, if anyone interested in helping, we still got a lot of work for this SoC to upstreaming, right? And to make it successful. And one big thing is the display controller, DRM, GPU driver, reverse engineering support, because I think everyone knows GPU driver, they will support upstream, right? So like the most predominant GPU, they saying that they only support Linux 5.1 kernel, 6.1 kernel. That's all they support, right? You're going to stuck with it. So that's same to us. The GPU is exactly the same. So we have to do research, engineer, and support. So everyone come down and take a look and help. And this is our example now. We have the hardware. We build in the 7.0 kernel and running on it. And just have serial, USB, and network, and PCIe. That's it. Just similar, very similar to x86. So that's all from me. Any questions? Thank you. And feel free to come to the RISC-V booth, take a look at all these, the pain we've gone through, and be part of it. Thank you.